Hello, ladies and gentlemen. So now we're going to start to summarize and make some observations. Okay, we've kind of looked at this already in the individual examples, but now we're going to tie it all together. Okay? So we have seen these two cases. If I have, like, let's say 2 plus 3, we get 5. The two numbers are the same sign, so the arrows that represent those numbers are going in the same direction. And so the arrow that represents the sum seems to have the sum of the lengths of the arrows that represent the two numbers being added. And we can see that the direction of the arrow representing the sum goes in the same direction as the arrows representing the two numbers that are being added. That's true in this case, but it's also true in this case. Here we're adding a negative, and we're adding a negative and a negative, so we're adding two numbers of the same sign, just like we are here, and the observations we just made hold completely the same here. The arrow representing the sum has the same direction as the arrows that represent the numbers being added, and the length of the arrow representing the sum is the sum of the lengths of the arrows of the numbers being added. So now what I'm going to do is I'm going to summarize that verbally for us, and then we're going to look at the case of adding numbers of opposite sign. So here I have a verbal description of what we just talked about, abstracting away from these examples. Okay, when we add two numbers of the same sign, the arrow representing the sum has the same direction as that of the arrows which represent the numbers being added, and the length of the arrow representing the sum is the sum of the lengths of the arrows which represent the numbers being added. Right? Look here. At this example, as we already mentioned, what's the length of the arrow which represents the sum? It's the length of this arrow, which represents one of the numbers being added, the 2, plus the length of this arrow, which represents the second number being added, which is 3, right? The length of this arrow is 2, the length of this arrow is 3. We add 2 plus 3, we get 5, which is the length of this arrow. And the direction of the arrow representing the sum is in the same direction as that of the numbers being added, right? Okay. Now, what about this situation? First, we can see that the direction is satisfied. The direction of the sum, here this falls under this observation because we're adding two numbers of the same sign, right? They're both negative. But so anyway, the direction of the arrow that represents the sum here is to the left, as is the direction of the arrows representing the two numbers being added. What about the length? The length of this arrow is 8. You can explicitly count it out if you want. 1, 2, 3, 4, 5, 6, 7, 8, right? And what is the length of the arrows representing the two numbers being added? Well, let's look at that together. 1, 2, 3. Aha! The length of the arrow representing -3 is 3. The length of the arrow representing -5, which you can count out also, will be 5. What is 3 plus 5? That's 8. So the length of the arrow representing the sum is the sum of the lengths of the arrows representing the two numbers being added. Okay? So you can see that this verbal description captures exactly our observations for these two cases when we're adding two numbers with the same sign. Now we're going to make analogous observations for numbers, for the sum of two numbers with opposite signs. Okay? So let's do that together.